Hello, my name is Sai, and today I just wanted to create a quick video talking about the autonomous robotic car that I created last fall, and that is really cool, and I hope other people can learn from this video and make it themselves. So the objective of this car was to traverse between three different points on the field shown, and between each of the points, find any obstacles and um, dodge them while moving between the points, and also at the final destination, detect an object and run into it to finish the program. The robot was built off of a thin board with many different components on top of it, including a compass, GPS, LCD, sonar sensor, touch sensors, and I also had two batteries connected over a common ground. One common ground for the Arduino Mega 2560 that was running the whole operation, and another battery for the actual motor and servo for the car. To actually control the motor and the servo of the robot, there had to be some modifications done to the wiring. So the servo and the motor each had three wires respectively. A positive power, a negative ground, and a signal wire. That could be used for PWM or so on. And the positives and the negatives for both of the servo and the motor had to be connected together because the motor controller actually provided power from the battery as well to the servo. So that was an interesting detail I noticed. And then the other thing was that the grounds had to also be connected together, but they also had to be commonly grounded with the Arduino ground. And then finally, the two signal wires were just connected into the Arduino I/O pins. So the actual build of the robot was just prototype, so everything was just mounted on there with either a combination of zip ties, screws, and Velcro. It worked really well. My robot was very sturdy throughout the whole process, and no big issues came throughout the whole time. I also used some custom mounts either from Amazon or 3D printed mounts I found online for these components. It was really cool to make the bump sensor, or the bump bar, I guess, on the top of the robot because I had to find the correct type of limit switches, learn how to, I guess, just bend them in the right shape. There's actually a kind of a perfect angle if you angle it in a certain way, as kind of can be seen in this picture. It works out much better than other angles that I tried out. And the bump sensor was really cool just because the main problem that I had was if I messed up coding or anything like that, and the robot started driving off in a direction I didn't want to and it hit something, I just set it up as an interrupt so that the whole program would be interrupted right once the robot hit something. And this prevented a lot of potential horrible cases for my robot breaking and stuff like that. So I would highly recommend that the bump sensor be installed before anything else. The sonar sensor was used to detect objects and dodge them, but it wasn't very reliable, and so that's why I made sure at the very end when I was trying to hit the final obstacle to just create a simple algorithm that would go and loop, I guess in an infinite loop, go through the final GPS point over and over again until it hit something. I know this is very crude, but the problem was I tried everything with the sonar sensor, and the issue with the sonar sensor is it can be affected um, adversely by wind or even just an uneven slope. Also, going along with the idea of safety is making sure that the robot's always on 2x4 blocks while it's being programmed so it doesn't run away while you're programming it and potentially either damage the robot or the computer you're programming it with. Another thing I wanted to mention was that I bought a $40 charger shown below, and this allowed me to charge my batteries in almost 4 times the speed and allowed me to do debugging very quickly and go through more test cases at a faster rate. So here's the final run of my robot, and I'm going to just kind of talk about a couple more things while the robot's going. So the robot did quite well, and it goes within each of the points marked within 1 to 2 feet. It might be hard to see that, but I assure you that it did. I hope you guys get some inspiration from this and decide to build your own projects. My code was designed in such a way that it's very modular and can just be used for a variety of projects. So I hope that that helps. And all the code is published on GitHub. So I wish you the best and thank you for watching.